Welcome to my YT channel. This is again at your service. I am a singer, Eternal Voice. Okay, this is another topic, but an extension to the topic that I discussed a while ago, more on the overview and basic concept of a redox, meaning reduction and oxidation, which is very essential in various chemical reactions. Okay, we need to understand this redox because this is very important in our higher chemistry. Okay, especially if your courses are BS Chem, BS Chemistry, okay, BS Chemistry, BS Pharmacy, Medical Technology, Bachelor of Science in Biology also, it can be, and then BS Chemical Engineering, of course, and BS Nuclear Engineering. I think University of the Philippines, Diliman is offering that kind of course, BS Nuclear Engineering, and it is also exciting, right? About nuclear chemistry. I love it. All about, the cellular atomic theory, something like that. I love that. Okay, but that is not our topic today. Okay, so this redox is very important in chemical calculations, or specifically stoichiometry, the study or the calculation of the stoichiometric quantitative relationship, meaning to say focusing on the amount. Okay, could it be in terms of a mass? Could it be in terms of any kind of amounts that we are referring to? It could be in terms of an atoms, a moles, a molecular weight, molar density, molar mass, like that. This, measurable items, shall we say, or quantifiable items, meaning to say have units. That what we mean of quantifiable and measurable, or amounts, specific amounts are being studied in stoichiometry as a subject, one of the subjects in BS Chemical Engineering. And I don't think so. Other science courses have this subject because I'm not studying their courses also. Okay, but I doubt they have this chemical calculations, of course, because it is very impossible, only theory without calculations, right? We need to understand further, especially for the laboratory test analysis. For example, in terms of medical technology, for the blood sample, urine sample, that is quantifiable and measurable, right? In terms of how many milligrams per deciliter of that total volume of sample, something like that. Okay, the level of triglycerides, the level of cholesterol. So it should be highly specific and measurable and quantifiable. Okay, that's stoichiometric relationship. Amounts. Okay, so before understanding that topic, specific topic, we need to understand the redox. Okay, and this redox is all about the electrons transfer. Okay, from one species to another species, or the electron transfer from species to species, something like that. When we mean of species, this is general word, general term. Okay, it could mean a compound, an element, an atom, an ion, or a molecule, something like that. Species, SPECIE, singular form. Plural form, species, SPECIES. And these atoms, molecules, okay, these are all species, including the element and the compound. Okay, something like that. Okay, we need to understand that there is a movement of electrons. Okay, so if there is a movement of electrons, of course, there's a transfer of electrons. And the only we can justify the movement and transfer of electrons is through losing the electrons and gaining the electrons. And of course, someone would release or lose the electrons, and someone would accept and gain or receive the electrons, something like that. And in order to understand clearly, because admittedly this topic really is sometimes confusing. When I was in college, I also found difficulty for this. It was about after my graduation or when I took up the chemical engineering review that I start to understand really the mechanics or or the principles or the foundations of this redox. Okay, because it was being discussed in detailed fashion of one of our review there in the University of San Carlos Talamban, then I can understand well. I took the review for 1 year. Okay, because I'm afraid really what's gonna be the result, and I took a lot of preparation for that. It's in there during the time that I slowly understand really it's gonna be like this, because during my first year college I really got confused. Okay, for this topic, for this redox, reduction, and oxidation. So, despite of going to library, most of the times I still found confusion. Okay, really, because it's instinct of an individual that sometimes you cannot understand clearly. Okay, and you have to dig a lot, study a lot, research a lot, and explore a lot, so that you can really understand what's going on with this topic that you'll be able to study, something like that. Okay, so during my review I slowly understand, and there's a little bit of confusion. Okay, honestly. Okay, then it was on the time that I already worked in several industries and companies that I almost understand 80 to 100% the behavior of this redox. And up to now, I still further research and review also the redox. Okay, then it's gonna be like this, something like that. Okay, so when you speak of redox, you must also take account, you should take into consideration the oxidation number, or shall we say the oxidation state. It's just have the same meaning, right? If we talk about oxidation state and oxidation number. Okay, now let's have an acronym first and abbreviation in order for us to understand quickly what we are referring to, because if we don't abbreviate and if we don't have acronyms and then we keep on memorizing long terms, then sometimes also we will be loaded of some terminology in our brain. And sometimes, that's really sometimes, it is really biologically accepted a theory that goes like this: our brain cannot retain most of the information 100%. It could only retain for at least 60% up, but it will never retain 100%. For example, if I am a student and my instructor is dissing, right, and then I'm listening to him, okay, my brain retention for those information will not permanent in my brain. Okay, I can only have 60%, 70%. Then if I write, okay, it will increase to 80%, like that, because the more you write, the more you listen, the more you write, it will increase your information retention in your brain. Plus, when you read it, another plus for your brain retention, plus memorizing it, so it will increase the percentage of understanding really those terminologies. Okay, listening, writing, reading, and memorization and memorizing. So the key important point prior to memorization is you have to understand what you are memorizing for, and you comprehend that very well. You should understand, because if you will not understand that very well and you did not comprehend that very well, then there's a possibility that it will be lost in your brain. Okay, so if it will retain to your brain for a longer period of time, this is what we call as stock knowledge. Meaning, stock knowledge is an acquired knowledge that is permanently stored in your brain. Okay, when you reaches the age of 20, 30, 40, 50, 60, even though your age will become higher already, you get older, you still have that terms perfectly in your brain. Okay, for example, density is equal to mass over volume, like that. Pressure, force over area. Okay, another formula for force is equal to mass times acceleration. acceleration due to gravity, 9.81 meter per second squared. Okay, these terms I memorized only one time, and then it will just retain in your brain even though you get old. Okay, like that. Those are stuck knowledge. You gain that from your acquired knowledge. It's different from IQ, your intelligent quotient, because intelligent quotient it is abrupt and quick. You can really picture out everything, what are the discussion all about from your instructors and professors, and it will be in your brain. So that is IQ. And you can really understand even if without memorizing that one. Okay, so that IQ is different from or the acquired knowledge. So in this situation, I am more on the acquired knowledge and stock knowledge because I'm not really that intelligent enough. Okay, I'm just above average individual. Okay, so this is only more on acquired knowledge basing on the stock knowledge when I was in my high school days and the college days like that. Okay, we go back now to the the acronyms and the abbreviation. Okay, and identification. Okay, I need scratch paper all the time during my discussion. Okay, I plan to buy a whiteboard in order for my discussion to be comprehensive enough. And then I don't know how to buy that one. I have the money, but I don't know how to transport that one inside my room. Okay, it requires vehicle, it requires car, and you have to go to the city to buy that one. Okay, then so that I can have my vloggings and live streamings very well, so that my audience can understand really also because if papers only is very small, okay, and then sometimes also the pencil pen ink will be consumed, and I kept on talking, and admittedly somebody could not also relate to what I am talking to. So it is only relatable to those sciences courses individuals who took up courses I mentioned a while ago, right? Courses that have sciences. But other than those courses, for example, business administration, Bachelor of Science in Finance, banking and finance, like that, the psychology, like that, or other any course that don't have science match. They have sciences, but the basic one, I think so. But they cannot relate more on me when I discuss, okay? Because the coverage are not their expertise also, not in their masterpiece, okay? Because they are on another courses. But if they want to learn something also, of course they will listen, right? Okay, but they found it boring because I am doing the conventional and traditional way of live streaming and vlogging. And I advise you guys to be patient enough to just sacrifice listening to me. Anyhow and anyway, my English communication is very clear, right? I pronounce it very well, right? So you can understand every word that came out from my mouth. Okay? So just sometimes listen very well. And then if you want also to jot down or to write on a piece of paper those terms that you are not familiar with, then you can do that. That is, if you are interested to the topic that I am delivering to you now in discussion, which is the redox. Okay. My gosh, where is my pencil pen? Oh my gosh. Here's my red pencil pen. Okay. My gosh. So this is redox. Okay. Reduction. Oh my gosh. In the context of chemistry, not in the context of another subjects, purely in the context of chemistry. Okay, reduction. Okay. Just listen. I don't have to write everything because it will take a lot of time if I write all definition. Okay, reduction. The abbreviation or the identification will be REG. RIG. Rig. Just think of an oil rig in oil exploration, in oil rigging, okay? Rig, R-I-G, meaning reduction is gain. Okay, so what is being gained? So the electrons. As I spoke a while ago, it is very clear that the electrons are being transferred. So the electrons are being gained. So rig, okay? Reduction is gain. So gain is the electron specifically. In the reduction and oxidation, we are talking about the electrons, ha? Not the proton, not the neutron, not the photon, not the positron. So those are molecular, cellular theory of atomic theory, right? If you can still remember. Okay, and then we have the oxidation. Okay, oxidation meaning the oil. O-I-L. O means oxidation, I means is, and L is lost. So oil is lost again. Sotero, what is being lost again? It's the electron is being lost. Like this. That is an identification. Okay? Acronym identification to let us understand very well. Okay. Okay. In my first year college, that was 20 years ago, in CIT University, before it was not yet a university, that is a plain institution. Okay. I understand that one, and I give the acronym of LOOX. Okay, LOOX. Okay, if you're a Bisaya there, just think of Look. Okay, so this is a Bisaya term, Look, and you know what I mean. So just very close to Looks. Okay, Looks, meaning loss of electrons is an oxidation. Okay, that's why Loox. And now we have Riga. Okay, Riga means, okay, reduction, and Ga means gain of electrons. Okay. Now, if it is undergoing a process of reduction, the substance is being reduced. Remember that one. From its term alone, there's no such issue, right? If it is undergoing the process of reduction, the substance is being reduced. Okay, reduction. So the substance is being reduced. Okay. Okay. Oxidation. Okay. Oxidation. So the substance is being oxidized. It's in the term only, huh? So you don't have to worry. Okay, oxidized like this. Okay, reduction reduced, oxidation oxidized. And we are referring to the element or substance that is being reduced, or it could be a molecule, an ion, an atom that is being reduced or oxidized. Okay, it matters only for the examples that I am be able to present to you later on. Okay, then now it's a little bit confusing. So if it is being reduced, so this element or a substance is an oxidizing agent. Remember? Okay, so it's the separate. That's make a little confusion, right? But just remember that one. Okay, if it is being reduced, for example, sodium plus chlorine will produce a sodium chloride, the table salt we have in our kitchen. Okay, something like that. So if we try to determine which is being reduced and which is being oxidized. For example, if the chlorine is reduced, example only, because I don't show the oxidation number, I don't determine yet, okay, the whole process. So if the chlorine is being reduced, so the chlorine is the oxidizing agent. Okay, correct me if I'm wrong, because that's what I understand. Okay, really, it's really confusing. Okay, and then for the oxidation, it is oxidized. The substance is being oxidized, the element, compound, or ion, or atom is being oxidized. But this substance, atom, ion that is being oxidized is a reducing agent. Because there is also question in the board examination, particularly in BS Chemical Engineering also, that you need to identify which is the reducing agent and which is the oxidizing agent. And sometimes you will be confused also if you will not be able to have the technique, the hint, and the strategy. How can you understand this reducing agent characteristic of a certain substance or an oxidizing agent? Then you have to understand also. Just put that in your mind. If it is undergoing a reduction, then that is an oxidizing agent. Or it is being reduced, that is an oxidizing agent. The reverse. If we have the word agent. Okay? So if there's no agent issue, then do not apply the reverse. Okay? So for example, if the process is in oxidation and the substance being oxidized, so the reverse holds true. So that is reducing agent. Okay? Because a lot of problems like that also in higher chemistry. Okay, so this is the basic. Okay, something like that. Now, if there is a loss of electrons, the low ox and the oil and the oxidation, the substance is being oxidized. Now, in oxidation, it's very important. Bear this in your mind because this is the more important one rather than the electrons, understanding because it's a little bit confusing. In oxidation, okay, there is an increase of oxidation number and oxidation state. So this is now very clear because it's referring to the figure or a number. For example, from 0 it will become positive 5. So there's an increase of the oxidation number of the oxidation state. So bear that in mind that that is an oxidation. So we represent an arrow up. Okay, arrow up meaning positive because we use that one in determining during oxidation and reduction. Okay, like that. So there's an increase of the oxidation number, arrow up. Okay, for the oxidation, and I will abbreviate oxidation number as ON, huh? ON. Okay, so that to make it easy. Oxidation, arrow up, ON up, meaning to say, in the process of oxidation, there's an increase of oxidation number or the oxidation state. Oxidation state is the same with oxidation number. Okay? Like that. Okay, and then the reverse holds through. And for the reduction, okay, there will be a decrease of oxidation number. So we denote that one or represent that one in an arrow down. Okay, arrow down meaning decrease of oxidation number in the reduction. Okay, in the process of reduction, there is an arrow down or there is an decrease of oxidation number. Okay, so in that way, we can clearly understand before giving an examples later on. Okay, and then in this redox topic, we need to have an understanding of the charges, the oxidation state, the oxidation number, and then the balancing of the equation through its number of atoms, of course. Number of atoms are being balanced, right? Okay. So since this is redox or reduction and oxidation in a basic solution, we need to have an idea. Basic is usually OH or negative. Okay. Our final equation will be added with OH negative in the end, in the last part, in the last step. Okay, because that is basic. Okay? Unless not specified, it's very confusing, but automatic it is OH in the redox. Okay? Because there's a lot of basic also substances. But the most basic is the OH. Okay, hydroxyl group, OH negative. Because we are more here in inorganic chemistry, ha? Okay? Not organic chemistry. Okay? It varies again to the context of your discussion. Okay? Like that. Now we need to have an example. Oh my gosh. Example. Okay, we go to the example. Okay, this is my favorite example. Charot. I use this example over and over again because I love this also when I was in my, first year college. I love this. Okay. Zinc. You know zinc? Zinc, by the way, is a raw material in the process of galvanization. Galvanization process to produce a galvanized iron sheet. This is a raw material. It is added with zinc. The process is known as a galvanization through the general process of alloying. Alloying, meaning a combination of different metals. That is alloying. Okay, but specifically the alloying known as galvanization because it involves the raw material as zinc. Okay, like this. Okay, remember that one also. Maybe it will come out also in the examination. Galvanization, zinc, charot, plus nitrate. Okay. I memorize because it's not very complicated. Okay. Nitrate charge is negative, right? And then we have the zinc 2 plus. Okay, do not be confused with the 2 plus and the plus 2. The 2 plus is more on the valence in the outermost shell of zinc. If you have the periodic table now, look at the periodic table. There is what we call as a valence in the outermost shell of these elements, arranged systematically. It could be horizontal, it could be vertical, and I think period is the horizontal and vertical is the family. I think so. Family 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A. So this, on what I remembered, 8A is, what do you call this one? A property that will never react anymore, stable. Okay, inert gases. It's in my brain. Okay, inert gases or what we call as the noble gases. Noble gases and inert gases will never react to any substances because themselves already in a stable. Okay? For example, krypton, xenon, neon, argon. So you will never say argon chloride. Okay, you will never say krypton dioxide because it will never react because in the first place, these noble gases and inert gases are stable, meaning to say they are not reactive. Okay, that's why we have argon gas cylinders, meaning to say that is not flammable because that is not reactive. Okay, like that. So these are all noble gases and inert gases in the family 8 last in a vertical family. And period will be horizontal like this, huh? Okay, based on what I remember. Okay? And there's also an electronic configuration in each element there. And I don't have to discuss because it's not our topic. Okay, zinc 2 plus nitrite. Oh my gosh. Diba? I already explained to you the polyatomic ions. So a lot. Then if you memorize them, then you can easily understand a lot. Diba? Chromate, nitrate, okay, oxalate, something like manganate, permanganate, like that. Sulfate, like this. Phosphate, like this. If you memorize the polyatomic ions, then it is easy for you to understand this redox. Memorize that also because it will come out in the redox equation. Okay? Do not memorize the complicated, but only the most common, which are always used as an examples in the textbooks and are always used in the examinations of your instructors and is always used in the discussion also of your instructors. Something like that. This is gonna be the example that I have. Oh my gosh. Zinc plus nitrate is equal to zinc 2 plus, okay, and then NO2. This 2 plus in the zinc, in a proportion of zinc, this is not yet the oxidation state, ha? Oxidation, this is valence in the outermost shell. Charot. Iwan ko ba? May ganun talaga. Pwede naman hindi lagyan, di ba? Nakakaloka. Okay. So, now zinc in its free state, this is neutral, meaning zero charge. Okay, if there's no charge in the upper portion, automatically we can declare that one as a neutral atom or neutral element. So that is zero charge. I will put Zn0, this one. Neutral, meaning it undergoes a neutral charge particle or zero. Okay, that's why a neutron has a zero charge just because of that. Okay, and then this one, nitrate. If you can remember the oxidation topic in chemistry, there's a rule for this if it is a compound, right? If this is a polyatomic ion or a nitrate, so we can have this one, NO3. Oh my gosh. NO3. The negative will be in the outside of the close and open parentheses. Okay, this is the overall charge of nitrogen and oxygen. Total charge like that. Okay, overall or total charge is the same, right? And you can get the individual charges or the oxidation numbers when we determine now. Oxygen, what is the charge of oxygen? Is negative 2, right? Put that here in the top portion of the oxygen. Okay, negative 2. See? Like that. Negative 2. And the nitrogen, we don't know yet. Okay, in this situation. So let the value of x as an oxidation number in this situation. Just like the balancing of the equation, always let x to solve for the value so that you can understand. Okay, x. Actually, you can direct, but I want you to understand why the oxidation number is like that. We need it to be in a, what do you call this one, in a systematic explanation, in a clear explanation by using basic and simple and linear algebra. Okay, so we have this one, x for nitrogen. We let x as the number of oxidation number of nitrogen in this compound or polyatomic ion nitrate. So x plus negative 2 times 3 is equals to negative 1. Okay? Because the 1 is the total charge of the nitrate. So x plus negative 2 times 3. The same principle with the atoms. You need to multiply the top portion. And now we will introduce another technical term, huh? So it's okay for you? Okay, we have the superscript. Okay, the superscript is written in the top portion. Okay, or any variable, but specifically this is superscript. We have the subscript, superscript, something like that, right? The subscript will be in the down portion. In this case, the subscript will be the 3 and our superscript will be the negative 2. In this manner, dealing with charges and oxidation number computation, we need to multiply the superscript and the subscript. But remember, the atoms, we need to multiply the coefficient and the subscript. Take the difference. From the charge or oxidation number, we need to multiply the superscript, the charge written at the top portion of an element, times the subscript, the number of that particular element down below. So that you can distinguish what is a charge and an atom. Okay, an atom is equal to the coefficient times the subscript in compound or any element, and this charge or oxidation number is the superscript written in the top portion of that element, each element, times the subscript. Okay, so that we can understand clearly. So it will now become x superscript of the nitrogen times the subscript of nitrogen is 1. If the number is not written, that is automatically 1. It's not written. Actually, that is in 1. But in chemistry, that is understandable to be 1. So x times 1. Since 1 is irrelevant already, so x. Okay, because that is only 1. So x times 1 is simply x, right? X plus negative 2 times 3 superscript or subscript of oxygen is equals to 1, which is the total charge of this polyatomic ion. So solve for the value of x. Algebra. Okay, x negative 6 is equals to 1. Therefore, x is equals to 1. Okay, like this. Therefore, x is equals to positive 5. Okay, like that. Okay, x is equals to positive 5. Okay, okay. So in this equation, the charges matters the sign. Okay? Because in the atoms, if you can remember, in the balancing equation of an atoms, we don't really focus on the negative and the positive sign, as long as you will multiply that one, right? But in here, we are very, very strict for the sign, the positive and negative sign. So if we are referring that the total charge and overall charge is equals to 1, negative 1, that is really negative 1, not only 1. Okay? Like that. So transposing is x equals to 5 and you put the 5 in the top of the nitrogen. So that is positive 5 here. Okay, I put already ha. Ganan. X equals to 5. Transpose man siya. After transposing, so the value of x will become positive 5. Right? Simple algebra lang siya. Okay? And then for the zinc, the charge of the zinc is positive 2. Okay, put that in the top portion. Okay. And for nitrite, the same principle with nitrate, use this principle. Okay. So I don't have to discuss really the automatic now because I really discussed the logic behind. So we need to have this one. So negative 2. Okay, so x will be positive 4. Actually, if you are already master for this, you don't have to use the algebra. You can now have the automatic assigning of the charges. But since this is sharing of information, and then not all of us can understand very well, even me, then I have to, present that in a systematic way. But here in the nitrite, we automatically do that because the same principle with the nitrate. Okay? So positive 4. Now, in this equation, zinc 0 plus NO3 negative, zinc 2 plus nitrate, we need to determine which of these elements undergoing the oxidation by using those definitions I told you a while ago. Okay, loss of electrons. And the loss of electrons is an increase in the oxidation number. In here, the increase in the oxidation number, could it be the zinc? Could it be the nitrogen? Or it could be the oxygen? Increase in the oxidation numbers. It's very obvious that it is the zinc from 0 to 2. So, oxidation. Okay. Oxidation. Then arrow up. Oxidation number. Increase of 2. Like this, ganon. And loss of electrons of 2 also. Ganon. 2 electrons lost. Okay? Okay. Oxidation, 2 electrons lost, and 2 electrons increase, arrow up, and then this zinc automatically will be oxidized. And then this zinc will be automatically our reducing agent. Okay? Labeled everything so that no more thinking in the end, right? Reducing agent. Okay. Now in the reduction, where's the reduction here? The gain of electrons, meaning the decrease of the oxidation number. Think if it is oxygen or nitrogen. There's only 2 elements left, nitrogen and oxygen. In oxygen class, there's no changes because this is negative 2 and the other one is negative 2. So this is neutral particle. So it is not the reduction obviously. So we are now on the nitrogen. Nitrogen in the nitrate and nitrogen in the nitrite. Charot. Okay. Now we put like this. Since this is gain of electrons reduction, okay, so there is a decrease of, think how many? Think how many? Decrease. Oh, right? Very obvious. From 5 to 1. So that is only 1. 1 electron loss and 1 oxidation decrease. So arrow down. Like that. So automatically, this nitrogen is being reduced. Okay. And then, this is also our oxidizing agent. Okay. Now, if the problem will state in the examination like this, in this redox equation, identify which is a reducing agent and which is an oxidizing agent, then bingo, you can answer perfectly. Okay, in this equation, blah, blah, the same equation I presented to you now, which is the following involves oxidation, you can answer also basing on this, and which involves reduction, you can answer also based on this, and you can answer so which is being reduced and which is being oxidized, answer also. So for example, if this is 50 points or 20 points, then you can now have a perfect 20 points in the examination. Okay, something like that. Okay, in only one equation only. For example, if this will come out in an examination, something like this. But this is only the first step. Identification of the oxidation reaction with its equivalent oxidized, reduced, reducing agent, and oxidized, equivalent loss of electrons and gain of electrons, like that, and oxidation numbers. Okay, now we go to the half reaction. What do you mean by half reaction, Sir Sotero? Half reaction meaning we need to cut only the reaction. We don't want to put all these reactions. Okay, half only. Okay, meaning for the zinc to zinc 2 plus and nitrate to the NO2 nitrite, we will break that one. That's why it called half reaction. And then in a requirement in the step 2, we need to balance first the number of atoms. The same as the balancing of equation that I taught you previously in my previous vlogs. Okay, we need to balance the number of atoms, and then secondly, we need to balance the charges. Okay, the charges. So 2. Here 2 now will be added. Okay, something like that. Okay, I think it's gonna be, I will continue this one. My gosh, very lengthy, right? Okay, we're on the step 2, the half reaction for this. Okay, I will continue later. Okay, this is the part 1 of the redox in a basic solution. I told you this is very lengthy. Okay, this topic. And we need to have the steps. The first step is to identify the oxidation and reduction. Number 2, do the half reactions of oxidation and reduction, and then balance it by the number of atoms, balance it by the number of charges in the oxidation number, and then number 1, balance the oxygen and the hydrogen. If you think there's a deficit in oxygen, then add water to that side. Okay, and then if it's a deficient in hydrogen, then add H positive for that side, like that. And then after that, add these 2 half reactions, balance the balance half reaction, and then you need to cancel which are those have a common variable, cancels that out. And after that one, it will be simplified your reaction. And after that, the last portion will be to add OH or the hydroxyl group in both sides, OH negative from the left and OH negative to the right, and then balance it perfectly. And if still there are to be cancelled, because the terms are similar, then cancel that out to make it simplified like that. But the clue there is to add OH in each side, because we are have the topic redox in basic solution. That's why we need to put OH in the last step, in the left side and in the right side also. But I'll have to stop now. The part 2, wait for the part 2 for the step 2 and the rest. Wow, step 2 pa siya. And it took me about 44 minutes in the discussion process. Again, I hope you will be able to be with me in my part 2 of this discussion, Redux and Basic Solution. And thank you so much for watching this live stream. Then if you want to comment, like, then you can do that in the comment section. And then if you're not subscribing yet to my channel, then it's about time to subscribe, because I have academic information coverage about health science, pure sciences, Okay, occupational safety and health, personal vloggings, and then also singing moments. Okay, of course, singing is my first love also. Okay, and then a little bit of mathematics. Okay, I forced to vlog sometimes a little bit of mathematics because it could not be denied. Mathematics also is a foundation of all engineers. Okay, something like that. No choice. Okay, like that. So those are my coverage in my YT channel. Okay. Okay, guys, see you later, and click also the notification, okay, the bell notification so that you can receive newest updates from me. I am a singer, eternal voice. Sotero, bye bye. God bless everybody. See you later. Wow.